Hello, welcome to Chapter 7, which is all about right triangles and right triangle trigonometry. So the first section that we're going to go over is 7.1, which is applying the Pythagorean Theorem. We're going to be able to calculate missing sides in a right triangle using the Pythagorean Theorem, and we're going to be able to classify triangles using the converse, and that's actually 7-2, so that'll be tomorrow's notes. So let's start off talking about what the Pythagorean Theorem is. When you have a right triangle and you know two of the sides, okay, so we're going to call the sides that are the legs A and B, and then the hypotenuse we're going to call C. So again, this is a leg, A is a leg, and C is what's called the hypotenuse. So the Pythagorean theorem says if you take the leg and you square it, and then you add the other leg and you square it, you will get the hypotenuse squared. So what's important to note here is which sides are the the legs. As you could tell, the legs come together, they form the right angle, so that's how you could tell that those are the legs, and the hypotenuse is the side across from the 90-degree angle. Furthermore, the hypotenuse is the longest side of the triangle. So if you ever get a leg longer than the hypotenuse, you know you did something wrong. That takes us back to chapter, I believe, 4, where we talked about the longest side being across from the biggest angle, and in a right triangle, the biggest angle is the 90-degree angle, so the hypotenuse has to be the longest side. All right, let's jump right in and start doing this first problem. So we are finding the values of x and y in the figures below. Well, we have to apply the Pythagorean theorem, so I have two sides. I have to decide which two sides are those. Well, since they come together to form this right angle, I know that those are the legs, so I'm going to take the leg and square it, and I'm going to add the other leg and square it, and I get the hypotenuse, which in this case is x, and I square it. So 25 plus 100 equals x squared. 125 is going to be x squared. Just like we always have to simplify fractions, we'd never leave something like 10 over 20 as our answer. We are not going to leave, once I square root both sides of this, we are not going to leave the square root of 125 as our answer. We have to simplify it. So x is equal to the square root of 125. I'm going to look for perfect squares within 125, 100, or perfect square factors. So I know that 25 goes into 125, but how many times? 5 times. Right, so now this part of the radical I could simplify because square root of 25 is a perfect square. It's a weird way to write the number 5, so we end up with 5 square roots of 5. Since that's the hypotenuse, it should be the longest side, and if I check that on my calculator, 5 times the square root of 5 is longer than 10, so I feel confident that that's correct. All right, let's look at example 2. We have here, let me erase what I wrote here. We have, again, a right triangle. Y is a leg, there's a right angle missing there, and 6 is a leg. So I'm going to take the leg squared plus the leg squared and equal it to the hypotenuse, which is always the side across from the 90-degree angle, and square it. All right, so squaring these values, I get y squared plus 36 equals 17 squared, which is 289. So now y squared, if I subtract 36 from both sides, I get y squared equals 253, and I would square root both sides to unsquare the y value. So in the previous example, when I had the square root of 125, 25 just kind of jumped out at me, and I knew that that was the value that goes into 125, the biggest perfect square. 253, I'm not so sure of. So when it's a number whose factors I'm not as familiar with, I do like to take that number off to the side, and I try to break it up into primes. So 2 won't go in there, 3 doesn't go in there, 4 doesn't go in there, 5, 6, 7, 8 doesn't go in there, 9 doesn't, 10 doesn't. What does go in there is 11 and 23. So both of these numbers are prime, which means the square root of 253 cannot be simplified, so I just have to leave my answer as y equals the square root of 253. All right, next example here is telling me to calculate the length of the hypotenuse of a right triangle with legs that are 7 inches and 4 inches. So I like to always draw a picture out for myself, so I'm just going to sketch a little right triangle, put the right angle in there, and then they told me that I'm calculating the length of the hypotenuse, so I could call that C if I want, I could call it H, I could call it X, whatever. The legs are 7 inches and 4 inches, which actually brings me to the fact that I've not been writing units over here. I apologize. In my previous examples, this should be inches, this should have been centimeters, and so on. All right, so I have the 2 legs. So Pythagorean theorem says 4 squared plus 7 squared is going to equal c squared. So 16 plus 49 equals c squared. That's going to give me 65 equals c squared. I square root both sides, and I get c is equal to the square root of 65. If I wasn't certain, I'm going to go off to the side and see what goes into 65. 5 times 13, both of those are prime, so my answer is c equals the square root of 65 inches. All right. Example number 4 says, calculate the area of an isosceles triangle with legs 13 feet and base of 10 feet. So again, I'm going to draw a picture. I'm going to make it as isosceles as I can. The legs, don't forget, if you have an isosceles triangle, the legs are the 2 congruent pieces. So these are each 13. And then they told me the base, the entire base here is 10. We want to calculate the area. So area of a triangle is 1/2 base times height, aka base times height divided by 2. Those are equivalent. So the thing that I'm missing here is the height of this triangle. I could draw it in because it's an isosceles triangle. When I draw that segment, that altitude is also the perpendicular bisector, it's the median, it's all those special segments. So what I do is I split the base into 2 equal pieces, which are each 5. So to calculate the height of this triangle, I'm going to just look at one of these triangles at a time, and I'm going to do Pythagorean theorem. I don't know the height here, so I'll call that h. So h squared plus 5 squared equals 13 squared. Leg squared plus leg squared equals hypotenuse squared. So h squared plus 25 equals 169. H squared is going to equal 144, and 144 is a perfect square, so h is equal to 12. All right, so now I could calculate the area because the area is the base of the triangle. Now don't forget, we were trying to find the area of the entire triangle. So the entire triangle has a base of 10. So 10 times the height, which I just found is 12, divided by 2. So that's going to be 120 divided by 2 is 60. And now because it's area, it's going to be whatever the unit is, which in this case it's feet, and then I square it. All right, last problem is a word problem. It says a 39-foot ladder rests against the side of the house. The base of the ladder is 15 feet away from the house. How high above the ground is the top of the ladder? So again, let's draw ourselves a picture so you can see what's happening here. Here's the house. And there's a 39-foot ladder leaning against it. Okay, that is going to be a right angle there. So if the ladder is 39 feet, that's going to be the hypotenuse of our triangle. The base of the ladder is 15 feet away from the house. That's going to be this distance. That's how far the base is away from the house. And then we want to find out how high above the ground is the top of the ladder. So that's the piece that we are looking for. All right, so leg and a leg. So I'm going to take my legs, square them, and add them together. And that is going to equal the hypotenuse squared. Okay, 15 squared is 225. Plus x squared is going to equal 39 squared, which is 1,521. I subtract 225 from both sides, giving me x squared equal to 1,296. Before I do anything, I'm going to check if that's a perfect square. So my calculator, I'm going to do square root of 1,296. And yes, I get 36. Now, in algebra, when you square root both sides of an equation, you do get plus or minus. We don't do that, and here we don't want the negative side because we can't have triangles who have negative side lengths. So my final answer is going to be 36 feet. And then I always just kind of glance and make sure that my legs are shorter than the hypotenuse, and 36 is smaller than 39. Okay, so that's it for section 7.1. That is the Pythagorean theorem. hopefully you've seen it before. I think we've done it before in this class, actually. So this should have been kind of a review. Thanks for watching. Have a great day. Bye.